This is pre-algebra, lesson 5-4, and this is going to be equations in percents. And what I'm going to do here is I'm actually going to take this to really two different levels today. I think that you'll find both of them to be relatively easy. Okay. So first of all, I thought there was a great problem in your homework last night that I saw some of you struggling with. So let's start with this idea of drawing a picture of a percent. Okay, drawing a diagram. It was actually number 1 in your homework last night. So let's go ahead and take a look at this one. Okay. First of all, they asked you to draw a diagram of 1 out of 1.25. Okay, draw a diagram of the percent of that. This is kind of what I would have foreseen you to doing in solving this problem. So, well, that is definitely not what I wanted. Okay, so I drew a box and I said, this is the whole. Okay, we are gonna, and some of the words we're gonna use are you're gonna see in today's lesson. Okay, so we're gonna call this the whole. And it's 1.25. Okay, so this whole box represents 1.25, or this whole rectangle. Now, do you agree that I can break this rectangle down into parts? How many parts? Yeah, 5 would be an option. Could I go more than 5 if I really wanted to? I could. I could go 10. I could go 100. In theory, I could go on forever. I could split it in half, then split the halves in half, then split the quarters, which at this point would be quarters, in half, and I could keep going on and on and on and on forever. In theory, that's true. However, probably the most useful representation here would be to split it into 5 boxes. So let's go ahead and do that. Okay, so we have 5 boxes. How much, if I split it in 5, does each box represent? Yeah. Okay, it'd be 1/5. In the case of this, it would be what? 0.1, 0.2, point what? Yeah, 0.25. Okay, if I have 0.25, 0.25, 0.25, 0.25, 0.25, that's 1.25. And each box does represent 1/5. Okay, so let's go ahead and fill that information in. 0.25, 0.25, etc. Now, what you were supposed to do in your homework is you were supposed to identify how much of this is 1. Okay, how many boxes would I shade in if I was to represent the quantity 1? Liam? Quattro, 4. So I'm going to go ahead and do that as well. Okay, so there is approximately 1 is shaded. How much of 1.25 is the part 1? Okay, so that's kind of what we're getting at here. So I have the part, which is 1.00. How many or how much of the whole is that? Yeah. 4/5. Okay, so really 1.00 over 1.25 is the equivalent, and actually I don't even need to put a squiggly because is 4/5. What percent would that be if I were to set this equal to something over 100? It'd be 80%. Okay, how did I get, and I'm just making this here's how we did this. We took the part over the whole, and we said the part is 1, the whole is 1.25. The whole always represents 100%. That, as kind of dictated by our diagram, is 4 out of 5, or 4/5 of the total. Okay? Your fraction here could have really been anything. 4/5 was probably the easiest to work with. And then how did I get from here to here? What did I multiply 5 by? Yeah. Yeah, I did. Very good. I multiplied by 20. And then what I do to the bottom, I must do to the top to maintain the value of the fraction. 4 times 20 is 80. So I see that by diagramming this, in essence, I'm able to find the percent, 80 over 100, or 80%. So 1 is 80% of 1.25. If you were to do this mathematically, many of you would just take 1, you'd divide by 1.25, and you'd get what decimal? 0.8. Okay? So that's kind of where we're kind of going with this today. Basically, this is today's lesson, in essence. And if you feel comfortable with this, then I think you will find today not to be too challenging. Yeah.
What was, like you just said it, like most of you would do
If you were to just take the part and divide it by the whole, you get the percent. You get the percent. Right. So let me go with that idea right now. Okay. If you would please go ahead, and if you didn't put this in your notes, at least start your notes now. Let's start with this idea of the part over the whole. Yeah. Yeah. You know what? I'm going to revise this just a little bit. Your part divided by the whole, and I'm going to say times 100 equals your percent. You will see some form of this equation every year for the next like 4 or 5 years. Okay, so I'm gonna start with this idea. We use an equation very similar to this in science class. When you are taking labs or are doing scientific analysis in high school, you're going to find what is called an error calculation. Basically, you'll take what you should have gotten out of a test result, and you're going to compare it to what you did get out of a test result, and you're going to be able to find what was called your percent error. Okay, a percent. So it's basically how accurate was your results, or how accurate did your data when compared to the real data, how accurate was that comparison? Okay, sometimes it varies. Sometimes to have 20% error is fantastic in science. Sometimes to have 20% error would be like the end of the world, okay? So it just depends on your lab, all right? Here, we're talking about general percent. So let's talk in terms of things that matter to you, your grades, okay? Let's say that you have a test coming up, you do, and let's say that eventually, next week, let's say that you are kind of analyzing what you need to get on this test, okay? I tell you how many questions it is, and you kind of want to figure out, oh, how many can I get wrong to get this percentage, okay? Some people do this. It's true. When you get to college, you will get to, like, there are professors that, and I did this only once, where they said if you have this percent in the class, okay, you don't need to take the final exam. So we would figure out exactly how much we would need to get to that percent. All right, how many points we could get off on that homework assignment, how many points we could get off on that homework assignment so that we didn't have to take that final exam. All right, so you can use this to your advantage, depending on the college and the professors that you have. Oh yeah, So because some of us were tricky, we actually spent more time probably trying to calculate what we shouldn't do than what we should just do it and be done with it. So needless to say. All right, let's say that you have a whole of 110 point exam. Okay, so let's say that you have a 110 point exam. Okay, that's the total number of points the exam is worth. Okay, and you want to figure out kind of different, like if I got 10 wrong, if I got 20 wrong, if I got 30 wrong. Okay, so you're going to make a mini little chart. You're going to make a mini little chart and you're going to say, okay, if I got 10 wrong, so minus 10, that would be a score of 100. If I got minus 20 wrong, that would be a score of 90. And if I got minus 30 wrong, that'd be a score of 80. Okay? Here's what I want you to do at your tables. I want you to tell me what the percent of each of these would be. Okay? Tell me what the percent of each of these would be. Go ahead and do that for me right now. Take maybe a couple of minutes and just tell me, what do you think the percent would be for each of these? So if you got a score of 100 or you got a score of 90 or you got a score of 80, what would be your percent? Because we're trying to figure out, okay, where's the A range? Where's the B range? Where's the C range? I literally had a friend who went into an exam realizing he only needed to get 10 questions right to pass the class with an A. Okay? So he went in, found 10 questions he knew the exact answers to, didn't put down any other answers, turned in the exam and walked out. The exam was like 200 questions. But he didn't need the other questions. He only needed 10 to get the A. He knew this. Okay? So he answered 10 questions that he knew the answer to, and he walked out.
How did he still get an A with getting an A?
He had done the math ahead of time. He knew exactly what his percentage was going into class, and he knew that if he got so many wrong, he would get a 95.001% in the class, which would have been an A, 4.0. He was fine with that. Yeah.
Yeah, but what if he missed one of the 10?
He didn't. He knew them. He studied, but he didn't want to spend the time. So he went in, answered 10 he absolutely knew the answers to, and turned them in. Yeah.
But he got an F on the exam. But wait.
Okay.
How do you still get an A in the class when you get an F on the
It was a points-based class. So his total points out of how many points he really needed was still enough. I mean, like some of the classes I've taken are 3,000 points. The class I just took was like 3,000 points.
Awesome.
So
like it's how many points out of like all your homework and all that.
everything.
I would still answer a little
So it's
more
not like
in case I missed
percent added up.
Right. It's not a categorical. So you got to know. So this also plays into how does your professor grade your stuff? How do they calculate your grade? See, you can really have some power over your own grades. I'm not saying go in and do that. I'm not saying answer 10 questions. But what I'm saying is, in college, you might have to make choices, right? Okay? I need a GPA of such and such to stay on the team, or I want to get into this prestigious nursing program. I need this GPA. Okay? So you might not have all the time in the world to study for every exam. Maybe for some reason your schedule got stacked that you have 5 exams in one day. You can't possibly study for all of them and be ready for all of them without being fried. So you have to pick and choose, okay, which ones am I going to focus on? Which ones am I not going to focus on? I'm going to focus on this one 10%. I'm going to focus on this one 30%. And so you have to start to play, okay, which ones are more important. Okay, yes. Yeah. Yes. The part is always going to be, well, not always. The part is going to usually be the smaller number. So, like the total number of points you can get, 110. So that's your whole. If you got 110, you get 100%. But if you got a 90, that's only part of 110. Right. You're not putting the points you got off. You're putting what you earned. That's very good. That's very good clarification. All right. Let's go ahead and do this right now. I'm going to go ahead and do this off to the side. All right. So this, what we would have had here 100, 110 times 100 equals what percent? 90%. Okay, the next one. 90 over 110 times 100 equals what? 81. We'll say 81%.
So if we had an 80,
Oh, an 80%, I would say is pretty good. Yeah, sure. That's a B minus. But
no, it's a C plus. Like if we go to 80%,
Hmm.
would that be correct? If this was on our homework?
81%.
81% is B minus.
I appreciate the the clarification. That's good. Okay, what about this one?
73%. Well, 72
Multiply by 100, Casey.
yeah, exactly. It'll be 73.
All right, we'll keep it here. I didn't do the math on a calculator, but we'll keep it there. 73%. Now, question, why do we multiply by 100? Okay, if we didn't multiply by 100, our answer is left in what form? It's left in a decimal form. Decimals, ladies and gentlemen, are not percents. They're a way to write a percent, but typically when you see 0.81, your brain automatically multiplies by 100 and says that's 81%. This is an actual, okay, if I want to know the actual percent without having to do the decimal conversion in my head, this is what I do. I take it, I multiply by 100. You will see this multiply by 100 thing again and again. I never did the multiply by 100 thing because I always did it in my head. All right? So if I did 100 divided by 110, I got 0.9. In my head, I knew that was 90%. But on paper, you still need to multiply it by 100 to get to that 90%. All right, the same thing with 90 over 110. You multiply by 100, you get 81 point something percent. 80 divided by 110 times 100 equals 73 point something percent. 72.7 percent.
So you don't actually have to multiply by.
If you can do it in your head, you're fine. Okay? But then here's where it gets tricky. Let's say you got 109 wrong.
That's a lot wrong.
Minus 109. Your score is 1. What is the percent? What is the percent if you get 1 right? What did you get?
I did 1 divided by.
Multiply by the 100. No. It's 1 divided by 110.
It's 0.9%.
What do you get as an answer? What percent?
0.9.
0.9%. 0.9%. So, for instance, you got 1 divided by 110 times 100 gives you 0.9%. You didn't even get a percent.
That's a pretty bad grade.
Okay. So, take 1, divide it by 110.
Oh, yeah, come on, Casey.
Okay. Shh. Hey. What's up? I did. And here's why. This is 0.009. That's the fraction. Sometimes people see that and they think, oh, 9%. No. If you multiply by 100, you move the decimal 2 places. 1, 2. So it's going to be, that's basically multiplying by 100 when you do that. Okay? So when you multiply by 100, you move the decimal and it becomes 0.9%. So sometimes it's very helpful to do the multiply by 100 so you can see the percent. Like for instance, some interest rates are only 0.25% or 0.02%, which is pennies. All right, so when you have decimal percents, not the same, not to be confused with a decimal version of a percent, but actual decimal percents, very, very small percents, you're going to want to make sure you're doing this correctly. Now, this all leads us back to the idea for today. If you look at your text, okay, they're asking you certain questions. What is 20% of 25? 5 is 20% of what? 5 is what percent of 25? Okay, they're giving you some examples here. So let's take a look at these three examples. We kind of did this yesterday, but I wanted you to be in the terms of parts and wholes and things like that. Okay, let's take a look at this example. What is 20% of 25? The biggest problem with yesterday's assignment, okay, was not knowing which numbers should go in the denominator or numerator, right? You can figure out the percents, but then trying to figure out, okay, which part goes where was difficult. So you can still do proportions if that's the easiest thing for you to do. So let's just start with that today. But now trying to take it a step further and figuring out what's the part, what's the whole. So what percent am I working with and how would I write it? Kennedy. Yeah, excellent work. So 20 over 100. Okay, and that's going to be equal to what? 0. Well, as a decimal, that would be 0.2. You're correct. But now the question is, okay, what is the part, what is the whole? Remember, P on top, W on bottom. Which one do I know? Which one am I trying to find? Okay, what is 20% of 25? 25 is the number I'm saying it's out of this. I need to know this is my whole. So 25 is the whole. And then my unknown would be the part, and it goes on the top. Okay. I'm going to show you a little bit of a different way of doing this today, okay, instead of cross-multiplying. You might find this to be way easier than cross-multiplying. I'm going to leave it up to you. I want you to do the method that you find the most comfort in, okay? If I wanted to get x by itself here, and I didn't want to go through the messy process of cross-multiplication, how could I get x by itself on this side? What could I do? Yeah, Jaden? I'm doing division. I have to do the opposite operation, or I would multiply both sides by what number? 25. Okay, so I'm just going to do that. If I multiply by 25 over here, and I multiply by 25 over here, okay, the 25s go away on the right, and I'm left with 25 times 20 over 100 equals x. Now, Liam just pointed out something that maybe he didn't even realize was going to be very useful here. But Liam said that the percent was 0.2 as a decimal. When you're working with, when you try to approach it from this method, the fraction is more messy. If you use the decimal, this becomes a very easy calculation. So I would encourage you to do something like this. 25 times 0.20 as the percent equals x. What you end up with is an equation that is your whole, your percent, and your part. And this is very similar to what you see on your paper here, okay? It's actually basically the second example, or one of the examples there, where you're taking the percent and you're multiplying it by the whole to find the part. So let's say that you wanted to find 20% of 25. Just take 0.2 and multiply it by 25. Okay? You want to find 20% of 25? Take 0.2, multiply it by 25. Do that right now. What do you get?
It's 5.
It's 5? That makes sense. Mm-hmm. If you find that the cross multiplication and proportion thing works better for you, that's fine. But this is a really easy way of doing this. Let me go back to another one here. I'll just do this right over here. This will be my last example for today. Okay? Let's say that I want to find 5 is what percent of 25? What are you going to do here? Yeah.
5/25.
Yeah.
X over 100.
5 over 25 equals x over 100. Yep. And you could, yeah, we just did it, but I'm trying to let you see it in a lot of different ways. Let me throw a curveball out there since that one seemed awfully easy. 7 is what percent of 31? What would you do here? Let's just say, I'm not even asking for a formal setup. I'm saying, what would you do quickly to solve this problem? Yeah. 7 divided by 31. You take the part over the whole, P over W. He's going to times that by 100 in his head. That's going to give him the percent. And it's going to be roughly 22%. You guys probably are starting to feel somewhat comfortable with this. The homework is going to ask you to solve it certain ways or write equations. I've tried to expose you to a little bit of that today, using the words part, whole, and percent.